Hello everyone, I'm sure you're doing awesome. Today we are going to take some deep dive into how Google Drive or the systems like OneDrive or Dropbox they are designed and how it works so seamlessly in that scale. The approach that we are going to take is incremental, that we will have a very basic problem statement and from there we will try to build a Google Drive. So let's take a very like a generic problem statement. Like suppose you are studying in IIT Bombay CSE, you are a topper of your batch and your university, and that's why you are being entrusted upon to build um, a system similar to Google Drive. Like you are being given a task to simple upload, keep it to file upload, simple file upload website. Okay, simple file upload website with uh, file sharing facility. Okay, so quite similar to Google Drive, but only for your batchmates. Okay, so initially, like it has been given to you that you will be writing this thing for your batchmates. Your batchmate is probably of 200 students, and for these 200 students, you are writing something called IIT Drive. Okay, so now let's start thinking about what are the things you have in your hand right now. So you have been given like a lot of AWS credits, so you can use the AWS infrastructure, or even you can build your bare metal services. So when we say bare metal meaning that uh, bare metal means that like we are just creating our own infrastructure, our own networking, our own virtual private networks, and whatnot. But as you already have AWS credits, so let's start with our basic AWS infrastructure only. Okay, so at first you did some research and you found out that what are the things that you can do is you need something like a Windows elements to get going. What are the things that you're going to need is you're going to have you're going to need things like Windows or the Linux OS. You're going to need some kind of a web server because this is a web application. So you're going to need some kind of a web server, maybe Apache web server or Nginx. You are going to have your MySQL database. So what will be the function of this database is, suppose you are about to store all the details of the file, the simple metadata of the file, like in which directory it is. So all those details we can store in our MySQL database. We will see it in more details. And so for this reason, what we did is in our AWS, we took a EC2 instance. So EC2 is nothing but Elastic Cloud Compute. It is kind of a virtual machine. Okay, so it is kind of a virtual machine that we are going to have, and we are going to have some kind of a hard disk to it. So what we are going to have is 1 terabyte of EBS or Elastic Block Storage. So don't worry too much if you don't understand what EC2 is or what EBS is. Just understand that there is a virtual machine, and in that virtual machine you are mounting some hard disk drive. Okay, so where user can upload their stuff, and mounting means making a drive accessible and usable for the OS. So it is just right now sort of a standalone machine with some kind of a hard disk drive. Okay, so just for your reference, how would our let's think that how would how would our file structure would look in our file structure look inside our hard disk. Okay, so suppose we are having like a number of students there, and I'm going to just copy paste it instead of drawing it away. That will probably save us some time. Okay, so we are going to have a drive. So suppose one of the student of my institute is named as Advaik Sharma, and what he can do is this assignments, he can create his own folder. So this folder will be created upon sign up. created upon sign up, and this folder will be created by the user itself. Okay, so we are going to have this kind of folder structure like created upon sign up, and user itself will create this subfolders, and in that he can create n number of files, or there probably will be some 10 15 GB space, or maybe more than that. We're going to store it here. So now that you have some idea what would be our folder structure, now let's see how would the table structure look like. Okay, how would the DB table structure look like, because we need to store all our data. So uh, I'm just going to again copy paste it for you so that we don't waste too much of our time on this. So here we are going to have a users table, and in this user table we are going to have this as a username. Probably we can have for example, for this first one, advik dot sharma at the rate iitb dot edu. Okay, something like that. So this can be our username, and it can be, there can be a primary key as well. So in this way we can keep on inserting our data. So our data insertion will look something like that. Okay, and this will be auto increment. So we have our users populated in this way. Okay, now from here one more table will be required is for our file structure. So this is for the users, this is for the users, right? And other than that we are going to require our files as well. So our files can be something like this. So there will be a files tables, and for every entry we are going to have a file name, and we are going to have a certain kind of a relative paths inside user namespace. So for example, Advik Sharma's assignments would look like this. So here in the file name it will be this name of the project, OS project, and this path will be assignment. So it will be relative to the parent folder of that particular user. Okay, so this is how probably a insertion statement would look like. Insert into files, we will give a certain user ID, file name, and the path and the given size. Okay, size probably we will determine when the file is already uploaded into our server. So this is now we have some idea in a single monolith, and in a single machine we have started building our database and our file structures for our database, for our users, and our file structure. So now let's get into our API endpoints. Okay, so this was users, and this will be files, and this will be files. Okay, so now let's get into our endpoints, or the how the API endpoints would look like. So the architecture will be very simple. Like there will be some kind of a user, they will hit directly into my API, and this API will insert the data into my DB. Okay, and this two things will be basically inside the EC2 instance. Okay, so my API server, my database server, everything is created into that EC2 server. So now let's think how our APIs would look like. Okay, how would the API look like? The first API will be something around slash files slash upload. Okay, so here we are going to pass a file name. Our request would look like, so we are going to pass a file name and the path. So this will create a file stream inside, and once it is successful it will just tell you that okay, your file upload is being successful. Okay, and the next important thing will be our download. So it can be something like files download, and we are going to request the path something like suppose someone got some kind of offer letter, multiple offer letter, so he is putting into a offer letter folder, and offer letter maybe from Samsung, so samsung.pdf. Okay, so this will be a request, and what it will return is it will return a file stream. Okay, and the response will be a file stream. So other than this two three, like so these two APIs, we are not going on a very high level right now, we are not going to need anything. But one important feature we haven't discussed yet is like the sharing feature. Okay, so we discussed the basic database users files, but we haven't discussed that if we have to share a file, how would our database look like. So one very basic thing we can do is we can have here a particular shared column, and we can keep on adding all the user ID with whom that particular folder or that particular file is being shared. But this is a bad design, because you have to take the whole data and you have to update it every single time. So your whole row needs to be updated for this particular file every time the user adds or remove some kind of a access to his files. Okay, so rather a way more sensitive things or a way more sensible thing is to do is this create table of shared files, having a separate shared files table. So what it will do is it will have a file path, and it will have the shared with which user ID. So now in case I want to share my uh, okay, one second, I want to share my project plan with some given user IDs. So I can just keep on do this kind of things, like read sort of a permission I can give to the user number 2, the write sort of a permission I can give the user ID 3, in this way. So shared file is going to be another table, and where for each file, each permission that we are giving into any of the user, we are going to keep on adding it over here. Okay, so now we have a quite a good project going on, and suddenly boom, you see that this is happening, like people have been uploading, and you see a report that your friends are saying that hey, I can't upload anything. Okay, I can't upload anything. So what you do is you go there, try to see what exactly happening with your EC2 instance, and you see that there is only 10 MB free out of the 1 TB data that you took initially. So now the first thing that will come to your mind is I will increase the space. Like, so the first solution, what solution you will do to unblock your friends? So solution might come like increase the space. So like increase the space from 1 TB to 5 TB. But then again, you know that the moment it will be expanded to different departments, currently only your departments and your year is accessing that. Suppose tomorrow the university comes and tells you that it will be expanded to first year, second year, third year, and whatnot, even the master's degree and on the other departments as well. So 5 TB will definitely fail in that very moment, the moment it will be scaled. Okay, so you decided to go with sharding your data. Okay, so now I think in case you don't have much idea about the sharding, you can just read about it, how we are going to segregate our data into different server. So now you are going to spin up few EC2 instances like the server 1, server 2, server 3, server 4, and you have some kind of a hash function to shard the data. And what you do is you put a all-nighter and you keep on dividing all the 1 TB data. You understand that okay, this is my this is going to be my user IDs, and this user ID will go to server 1. So you basically create all the databases. So this server 1 will have one database and this server 2 will have another database, something like that. This server 1 will have one database, okay, and server 2 will have another database. Suppose it will have all the users from like user with user ID 2 to 2000, okay, 2 to 200. And in server 2 you are going to have like a user from 201 to 400, something like that. So this is how you divide your database and the file systems, and in those file systems you are going to put the corresponding user range data. So here the DB, like database, will be centralized. This will be our file system. This will be our file system, and probably our database. So here also I have put as a file container, but treat it like this, that this is the database and this is the file container, or I can even remove this, I think, to delete the confusion. So this is my containers, file systems, and this is my database, okay. So in the database I'm going to do this query, and I know that after dividing my data they will be residing on server 1 2 3 4. So now server 1 have like some given space, and you also do some kind of a logic that suppose any other year comes, you are going to put those years data into server 5. So in this way you kind of get some idea, or you do some kind of a firefighting, and you make sure that your single server is going into a distributed mode right now. But things are still lurking in your mind, like what if this server also keep getting filled up, and in some server, suppose tomorrow university comes and say like look, instead of 10 GB, I think we should give each user 100 GB space. So then another new massacre will happen. So previously suppose the sleep for each student it was 10 GB. Now they have increased it to 100 GB. So that will be a very problematic scenario for you if you are maintaining year wise server. For example, all the computer science year one, even the server one won't be able to handle that much amount of data, okay. So this is one of the problem that is in your mind. But right now one practical problem also happened. So suppose you just get to see that one of your server, one of your EC2 instance just failed, okay. So one of your EC2 instance just faced a hardware failure, and trust me, you haven't taken any backup or anything. So the machine that were there, it is just gone. So now what you do is you understand that this is also not a feasible approach, because the moment some server is gone, suppose this server is gone, all the data, you do not have any backup or anything, all the data are just gone. So now what you need to do, you go to your friend Vivek, who recently interned at Netflix. So he knows some things about the storage of data, because Netflix stored that huge amount of video encoded data, right? And surprisingly it uses S3. So your friend suggests you that whenever you are having data like this which can incrementally grow up and you don't know the limit, then and those are in kind of a file structure basics, you can always use S3. So for then when you start exploring, you understand that S3, or the Amazon Simple SQL Storage, AWS S3, because we are having AWS credits. So what we are going to do is we are going to just put S3 as our system right now. Okay, so this is the kind of a decision that we got because of these failures. Now this is how exactly we are scaling our infrastructure into something like Google Drive. And you also understood that S3 is not just a file storage. The things that it gives you, like a enterprise scale replication. So replication means, like, even if one of your server or anything goes down, you are always sure that your data will be available and it is durable. There is no data losses happening, and also at no point of time S3 might go down, because it provides a very very high SLA. I think 99.9999 some percent, which probably would lead to some 3 to 10 minutes of outage in a whole year probably. So you can be rest assured that there won't be any like a scaled outage which might cause any problem to your data. So now what you start doing is, you decided to move your file system to EC2, from the EC2 to the S3. Okay, so to translate our concepts now, the kind of folder structure drive we have. So drive, it was our parent. Okay, so here our parent will be a bucket. So one S3 bucket we will create, and what we are going to have inside that is, each user is going to have a namespace. So namespace is nothing but kind of a folder you can think about. And if you are not sure about what bucket is, there is another video in our system design series where we have gone into very detail into S3. So probably after this video you can go to the S3 and understand the internals, how bucket and the other nitty gritty around the S3 works together. Okay, so what it will give us is, it will give us some kind of a S3 object key. So before, things were like this. If I can just put things into perspective. So suppose there is a user called Aditi Sharma, and she is going to have something like this in the file system. Okay, and now what the new after migration into S3, what we are going to have is, we are going to have something like this. Okay, this is in the AWS S3. Okay, so in the file system we have something like this, and in the S3 we are going to have URL. Through that URL we can access the particular file. Okay, so now how the bucket looks like. So now we have this IIT drive bucket. Okay, so suppose we name it as, instead of drive clone, we name it as IIT drive. This IIT drive bucket, we have the names. These are namespaces, and we can keep on creating folders as a user, and we are going to upload our files into that. So now there will be changes in my file upload API. So what will happen now is, so API changes will happen. So our base API will be same like the upload, but S3 gives us separate API to upload our object into our bucket. Okay, so what we are going to do is, we are going to just take the object and we are going to pass into our SDK. So S3 gives us like software development kits and APIs through which we can just upload our data, like simple code like this. Okay, and the download is nothing but a GET request. For example, when I'm downloading the data, so download in a Python code would look very simple like this. Okay, so the first one is API changes of this is the upload, and this is the download. So we are having a bucket, and we are going to pass the key at the time of downloading it. So tree will be the full structure or the full path of my document, and we are going to get the data as a response. Okay, so now let's talk about how the flow would look like in a more formalized way. So from the user, the request will come to our EC2, EC2, where we can say that our API is running. Okay, like the API which will cater the upload and the download request, suppose that is running into the same EC2 instance where we started off. Okay, and of course there is also one EBS volume is associated with this one. Okay, but this EBS is not our concern right now, so we will just go to the S3. Okay, so what will happen is from API we are going to make a call to S3, and in the upload flow it will be a put request, and in a download flow it will be a get request. And once it is successful, so this is interesting, once data put is success, what we are going to do is we are going to put our data into our database. Okay, so previously we were putting our database in a probably initial stage only, but now what we are going to do is once the data put is success, we are going to put we are going to put our data over here. Okay, this will be our database, this will be our database. Okay, now still your problem doesn't finish. So there are two very problematic area we have. One is this, because this is a single point of failure. The moment my API goes down, I do not have anything else to do. Okay, and suppose IIT IIT databases are being suffering because of something like a DDoS attack, and in your EC2 instance you do not have any any guard any guardrail so far, and because it being a single point of failure, it goes down, and no one from your batch or no one of the fellow students can now access their S3. And again, the similar thing can happen with the database as well, because the database is right now in my EC2 server. So what might happen is the database will might also gone into some kind of a bad state, because we are keeping everything into a single machine, and that machine has gone into like a that machine literally got killed, or some hardware failure or something might have happened. Okay, so now the first thing is take the database out. Okay, take the DB out from our EC2 instance. And what we are going to use is there is something called in Amazon, in AWS, that is called RDS. AWS's relational databases, it supports various kind of relational database. So we are going to take our DB out to make sure that in a single point of failure, our database is not getting affected by any means. Okay. So the next thing what we are going to do is we know that if this EC2 instance gone into a killed mode, then our services will not be able to serve our services will not be served, and nobody will be able to access their data. So now as a second rule of the distributed of distributed system, what you are going to do is you are going to scale the API server and make sure it has fallback as well. So for that, one of the very good uh, good approach is something called the auto scaling group. So suppose I'm getting like too many number of requests. Suppose the end semester is going on, and probably in a single second your API server can serve 100 requests, but suppose for some reason saw like some 500 requests, then how you are going to handle it? So in that case, auto scaling group will come in play. Again, scaling, these are a bit of a basic thing, so I'm not going detail into it. But what will happen is instead of sending the request here, our request will come to some kind of a load balancer. Okay, some kind of a load balancer, and we are going to have, instead of a single point of failure, we are going to have multiple EC2 instances. Okay, we're going to have, let me write it like this. We're going to have multiple EC2 instance. So whichever is the healthy one, we are going to route into that particular one from this load balancer. That EC2 instance will is going to serve the API. So now if you see, we have a perfectly scalable and a distributed architecture. Like we are not having any scalable any scalability, basic scalability issue here. For example, we have divided our a single point of failure into auto scaling group and abstracted it access through a load balancer. And S3 is anyway, like, it is being known as a highly available success. And for the database also, in the RDS we mark it as a two-factor replication. So two-factor replication means like at least two database will be there which will have the similar data being synced. Okay, so now there are few problems. Our problems that we are going to face now is not simple node failure. Now our problem will be more concentrated and more on the system specific. So what will be the first problem we are going to have? The problem that we will face is now multiple file upload conflict. Okay, so what exactly multiple file upload conflict? Let's take an example and try to understand what happens here. Okay, so suppose there are two users, okay, and they are working on a shared file. Take this as an example. There are two students, Rohan Mehta and Neha Patel, and they are working on a same shared file. So what happens is at the point T1 or timestamp T1, okay, so Rohan, here I'm putting it, okay, let me put it a little on this. So here Rohan, he updates the project plans, project plan.md, okay, and in T2 what he does is it he adds one text, use AWS Lambda, okay, and in T3 he saves the file. So suppose we are dealing with the v1 version 1 of the file, so he saves the file and it gets saved as v2. And in a similar timeline, in an exact similar timeline, Neha is also operating. Okay, so what Neha will do is opens the same file, and instead of AWS Lambda, she on the same line she writes use Firebase, and it's saved as version 2. Now what will happen? Now you will see that from the initial state we are having a conflicted version 2. Okay, we are having a conflicted version 2 as the server gets the request at very same time. Okay, now there are multiple approaches to it. There is no one single way to resolve the conflicts, but what we can do over here is, suppose the moment we are saving, okay, so suppose from here the data save is going on. So from server to, when I say server, it is API server. From server to S3 data save is going on. Okay, so what will happen over here is from server to S3, Rohan's V2 will go. Okay, suppose it goes in a fraction of seconds, and on that very fraction of seconds, the V2 from Neha also goes, but Rohan's was first. Okay, was first. So now that I have V2 as my current version. So current version is V2. Okay. Now the moment Neha is trying to change it, Neha will see, like this request from the Neha will see V2 already exists. Okay, V2 already exists. So now what it will do is it will try to do something like a auto merge, and there is not a single strategy. There are like n number of strategy, or it will return user the conflicted file and ask user to resolve it. Okay, okay, now this is gone. So sorry, so now this is done. That a basic conflict resolution, how it is happen is, it is basically checks the version, conflict resolution done via checking the version in server whether client has the latest or not. Okay, and based on that, multiple strategies as we were discussing, like it can be self correction, or it can be like a user enforced connection. Multiple things can happen over there. Okay, so this is what how Google Drive internally also handles the conflict resolution. Okay, now in systems like Google Drive or Dropbox, there is a very interesting way how a large file upload is being handled, and how it's failure. Suppose some kind of a failure of the network, or some kind of a failure from the user side, or the systems are not in the sync. If anything around that happens, how the large file upload and its failure is being handled. So here a new thing that I want to introduce, that is called a block server. So what happens is, suppose Rohan is uploading a file. Okay, suppose Rohan is sitting there, and what Rohan will do is Rohan will pass his API request to the web server. Okay, so now that web server has the request, what it will do is it will create a block of the data. So this request that came, suppose for a 1 GB of date 1 GB of file. Okay, and this request will first go to something called a block server, which particularly handles the upload. So what does this block server would do? So block server, what it does is, suppose it is a 1 GB file or a 500 MB file. So let's to make our calculation, let's take it as a 500 MB file. Okay, so this 500 MB file will be divided into different blocks. Okay, will be divided into different blocks here. All right, now if this is like a first time upload, what it will do is it will keep on adding all those values into our drive files. So based on the timeline, what it will do is it will keep on inserting the data into our drive files as different blocks. Just pay attention to this part. Okay, so there is this block IDs. Okay, so I list all of my block IDs, and also what is the file size, and what is the checksum of the and what is the checksum. Okay, and whether this file is completely uploaded or not, or pending status, all these things I can track via this table of mine. So again, what exactly happens is Rohan uploads into web server, then the block server divides it and also compresses it, and then it will keep on inserting the data. It will keep on inserting the data here, and of course, like if anything fails, proper retry, proper encryption, all these things will be taken care. Okay, so now that we know that our file is not a single file anymore. Okay, so we are having a kind of a block of files. So now suppose user is making some changes into the file. Suppose user made a little change into few of the frames of the file and starts re-uploading. Like this has been one of the presentation video that Rohan prepared, and probably in between he stammered a little bit. He to reduce or to remove that stammering, he made some update and just upload the same file. So suppose it is like project presentation.mp4. Okay, he is uploading the file. So now again we are going to divide it into this block server, and during that block upload, it will keep on checking that whether that particular block is already there or not, and whether its checksum matches or not. In case some block is not there, or their checksum is not matching, what it will do is it will just re-update the block. So in that case, at the time of re-upload, what happens is only the blocks, okay, at the time of re-upload, only the blocks which got changed is uploaded. Okay, and who tracks it? Like checksum tracks it. If any checksum mismatch happens, if any checksum mismatch happens, then as simple as that, like it will just replace that particular block. And what block server does is, block server also maintain a temporary drive of files. So in this process, what happens is, let's try to understand the failure and the track, then we will totally understand what happens in the block happens. So just if the file upload fails or partially succeeded, okay, or partially succeeded, okay. So what happens in this case? So let's take an example here. So at first, from our browser, we are going to make a request to our EC2, and each of our block data will be stored in our block server at an initial level. Okay. So let me write it down at first, then probably we'll put it into a uh, diagram. Okay. So in an initial upload session, what happens is there is a file called project video.mp4. It is getting uploaded with a given path, suppose group project, final year, and yeah, here will be, and some project video.mp4. Okay. And we also, the moment it gets that API call is being made, I also calculate how many blocks can be there. So I understand there will be 32 blocks. Okay. So now there will be a upload session in our database. So this is the step one. Okay. This is the step one that happens in this. Okay. And now in the step two, what will happen is we are going to create a upload session in database. A upload session will be created, a new table. How the upload session would look like is something like this. I'm just going to copy paste it. So you see, we have the user ID, we have the file name of that, and we have the total blocks and the status, okay, whether it is a in progress status or not. And the important thing is it will give us a unique session ID to track the upload. Okay. So the moment we make this request at this, okay, once this insertion happens, the in the response we get is some session upload file session ID. Okay. Upload session ID. All right. So now in database, I have a upload session and I also have a given session ID. Okay. So what will happen in the next stage is, one by one, these blocks will keep on getting uploaded. So now from the block server, now the things are there in the block server. So what this block will keep on doing is, block will, our block server will take each block and keep on uploading. So how would our request would look like? Our request would look like something like this. So there will be a given session ID. There will be a given session ID. there will be the block number, and after block number there will be a checksum that I will be maintaining, and after that the actual data, like it can be a binary formatted data, which will be which can be changed in a different way once it is uploaded. Okay, so block server here, this is done by block server here will compress and encrypt the block, and there will also be another table. What it will keep on doing is, in case any block gets failure, for retry mechanism in our database, block server will keep on inserting this value. So suppose there is a given session, and whether it is a uploaded or it is a failed, all those status it will keep on inserting here. So now suppose once the all the upload happens in a parallel way, we can always have our flags to check that okay, this is a particularly failed upload, and I can keep on retrying it. So this structure of maintaining the block status, okay, and maintaining the upload sessions together, they gives you an architecture to make sure that if any block upload fails, how do I make sure that it retries. Okay, so suppose there is a network disruption happens. Okay, network disruption happens, 1 to 15 done, but 16 to 32 not sent. Okay, so now what will happen is, once all blocks are cleared, insert into the files will be happening. So the moment we see that all my blocks here, okay, all the blocks from the in progress status, when all the blocks will be success, this will be marked as a success. So then only what will happen is, in my actual database the file will be inserted. So you remember, like we have earlier created these drive files, so then only this file will be created. So once all of these things successful, like this fail, after retry this is success, then only what will happen is, this data into the drive files will be inserted. Okay, so now if I just have to formalize it in a little bit more way, so there is a client browser. Okay, so there is a client browser instance. From there, a post request of slash API slash files upload will go into our EC2. Okay, and from EC2, what will happen is, it will insert the data at first to the insert the upload sessions, insert the session data into our database. Okay, so using that database data, we will now, here the block server will come in between. So once this thing is done, okay, this will be our step 2 basically. So step 1 is making this post. Then what will happen is, in the step 3 our block server will come in play, and our EC2 instance will keep on sending the blocks one by one to the block server. Okay, and block server will also maintain, so this is going to be like the number 3, all the blocks will keep on sending, and at the same time the block server will also maintain in database. So the first one is basically the upload sessions table, and in this case it will be block status table. Okay, which we saw, block status table. So once in this upload session we get a success, and this block status, all the blocks are successful, what will happen is, then only thus then only we are going to mark a success into our mark it as a success into our file system. Okay, this is our file, this is our files table. Okay, this is our files table, and what block will keep on doing is block in the S3, it will keep on uploading the blocks one by one. Okay, so this is how we are going to handle our failure. I think you got the idea that in case any failure happens, this block data will be in a failed state or in a pending state, and whatever the data will be in the pending state, it will be the responsibility of the client program that we will be writing. Suppose it's a website or a mobile app, from whatever place we are doing the upload, it will keep on checking these two tables, and whichever the block that is um, whichever the block that is not being uploaded, it will keep on uploading the blocks. Okay, so this is pretty much it, guys. Like we have covered uh, what how exactly from a very simple monolith we scale it up into a million user thing, and also alongside we tried to handle the failures and the request when if the system is gone into a conflicted mode. So if you have made till this far, I'm sure there are few things you have learned on the way. In case you have any question, please put it into the comment box. I will try my level best to answer. See you in my next video. Till then, stay awesome. Thank you so much.